If you can't do great things, do small things in great ways. A very pleasant good afternoon to all. I'm Pooja and here is my teammate Anita from Team Tech Warriors here to present about SC Converter. Here we present.
Electricity is one of the major discoveries that changed the life of people on the planet. Electricity is a key component to modern technology, and without it, it is very difficult to run a day. Our mobile phones, our laptops, our computers, everything around us requires electricity. But due to the demand in the non-renewable sources, the scarcity of electricity increases. So we need an alternative source of energy. But do you think that sound is a source of electricity? No is the answer. This hidden source of energy is now emerging in the new era. Sound that we encounter every day is a source of energy that is often overlooked. The noise pollution gives unwanted noise into the environment. This noise can be converted into electricity. The solution for this problem statement will be explained by my teammate Pooja. Over to Pooja.
The objective of this project is to convert unwanted sound energy into useful electrical energy. As we all know, energy can neither be created nor be destroyed but can be changed from one form to another. The sound is basically a mechanical wave. When sound travels through any medium, it disturbs the particle of that particular medium. So this disturbances which is caused by the sound can be used to produce electricity as per the law of thermodynamics. Noise is captured from different resources and it is converted into electricity using SE converter. SE converter works on the principle of Faraday's law of electromagnetic induction. That is, induced EMF is directly proportional to rate of change of flux. The generated voltage, that is EMF, depends upon velocity of the conductor, magnetic field and length of the conductor. The electrical energy is then stored in battery and used for further application. Over to Anita.
Now let's see about the flow of the project. So sound is captured in terms of decibels. So the design of the device will be like, first a diaphragm will be placed, then followed by a coil and the magnets, then it is followed by a rectifier, booster and a battery for storage purposes. The coil will be placed in between the magnets. So when the sound waves hits the diaphragm will fluctuate, and due to that fluctuation, the coil will rotate. When the coil rotates, it will cut the magnetic field. Since the coil is placed in the between the magnets, the magnetic field will be created, and when the coil rotates, it will cut the magnetic field and an EMF will be induced due to the variation of flux. So this is basically the principle of electromagnetic induction. And since the output is AC, it will be converted into DC using a rectifier. Then this DC output is boosted up using a DC-DC booster, and then this is stored in a battery and used for further applications.
The technology that we use here are DC-DC stepping up, voltage amplification, AC-DC conversion. For DC-DC stepping up and voltage amplification, we use booster which boosts the voltage. And for AC-DC conversion, we use rectifier which converts AC into DC. The potential use case. This device is applicable in noisy environment. Noisy environment, here what we mean is the place where the sound produced is 100 decibel or greater than 100 decibels. Some sources are textile looms. In textile looms, nearly 100 decibels were produced while running the machine. Secondly, pig farms. A single pig can produce up to 103 decibel. This device can be placed in pig farms for more efficiency. Airports. Flights can produce 120 to 140 decibels while taking off and landing. So our device can be used in airports. Rocket launch. During rocket launch, 180 decibels were produced. So this device can be used in spaceport. Printing press. Printing press produce nearly 95 to 100 decibels. There are many sources available. Our device is mainly used in two different scenarios. DC applications like LED bulbs, alarm clock, calling bell and so on, and directly used as a battery. Here, the output electrical energy is stored in battery and this battery is used in wall clock, toys, and other battery-based applications. Over to Anita.
Now let's see about the budget estimation. Our device costs nearly 715 rupees and the cost depends upon the components which we use. The main components which we have to use is these 6 components, and they are diaphragm, coil, magnets, and a DC-DC booster. It is LM2596, then a battery, and finally a rectifier. Over to Pooja to explain the marketing strategy.
Art out of phase is the main idea of our project. The unwanted noise is converted into electricity.
Now everyone will have a question in your mind that will the voltage generated be it will be enough for running an application.
This question can be answered by a quote. Little drop make the mighty ocean. The small voltage that is generated gets added up and used for greater applications. This can be used as a UPS when there is no electricity. Consider a situation where there is no electricity for consecutive days. By using this device, electricity is produced from nature like sound from pig farms, birds, thunder, etc. and used for emergency purposes. And this can also be used in smartwatches, Bluetooth earphone charging and many more. Another advantage of this device is its replacement is easy and cost efficient.
These are the references which we refer for this project, and sound is present enormously in nature and we can use it for producing electricity. This technology is not practically used now due to some efficiency concerns, but researchers are working on it and surely there will be a better future for it. Thank you for the opportunity. Save electricity, energy is the future. Thank you.
Quote is very good. Okay, definitely it will make a person, but if you are arranging in a series or parallel of this type of sensor, could you calculate how much it produces?
So for the 70 to 75 decibels, sir, we got
That's
like
the minimum threshold level, yeah.
is
Of
sir.
course,
Yes,
75 only you can able to convert
Yes.
energy.
Yes, sir.
They have any existing data.
So we referred a research
For
paper.
example, we have 150 decimal available in place outside. So that we continuously expect the energy one hour. How much energy can able to move from that area?
So for 70 to 75 decibels, we can get 3.5 voltage, sir. So for 150, it will be just double, sir.
And we can increase this voltage using boosters.
Using okay, no, but aircraft or a rocket or whatever the decibel it may be, the rotating, that is diaphragm will move and rotating the coil. Okay, could you place a 1 meter dia coil in that particular diaphragm? If you are focusing all the sound on the particular one, that is possible. So definitely from a vibrating system you can able to get a EMF. So the electromagnetic principle or the vice versa is same. Either the magnet is moving within the coil or the coil having a magnetic flux, you can rotate the rotor like that. Okay. So why are going for a rotation instead of reciprocation? Coil rotating பண்ணணும்னு சொல்றீங்க, instead of reciprocation போனால vibrate ஆகிறது reciprocating from a fixed point to reverse point. Within that point it will be reciprocated. So in that cases you can use a magnetic piece or a coil is going to move within either the coil or a magnetic flux area. You can get an EMF. Okay. Then the last point. You can generate a EMF from a drilling machine sound, and you can feed it again in the sense there is no energy loss in that particular one. If you are saying 100% efficiency, more than 100% efficiency of that particular system. already the drilling machine is doing some work, definitely it will be taking some more energy to do the work. Remaining is wasted. The wasted what? Like an sound energy. That sound energy you are using to generate a EMF. That is not enough to run the drilling machine. Okay. So definitely it will be used in some places like charging mobile and other small factors. The milliamp powers like devices. We can search it in the Google. We can have a number of devices for an electronic gadget charging items. Then what they are using. Definitely you can focus on that particular point. You can have a good idea in that charging type of mechanism.
All the case. So whatever you generate power from your device, it has to power up any of the devices or any charging. On the aspect of the utility. And also for operating any electrical appliance, you need a minimum voltage. So in your device, how can we generate the voltage and the power?
Electrical second year. While okay, second year they are come front of the forum and telling the new ideas.
The idea
or
is
some
novel,
ideas.
but how you are going to implement it?
Now finally, the Tech Titans team may come over.
Can you start, sir? Good afternoon, or should I say good evening? Because it's almost. So we are the Tech Titans. I am Dhananjay from AC second year, and this is Gunal A. So we are working on the idea of automatic solar street lamp using an IoT module. And over to Gunal for the problem statement.
We have seen a lot of accidents occurring due to driver, cyclists and pedestrians. These are the reasons for common accident. The lot of there are other reasons due to the accidents can occur. It is of unavailability of street light or defect in street glass or not properly on and off of street light may also lead to lot of accidents nowadays and theft. So that we have come up with the solution for that. It can be.
Okay, so the solution we propose is a simple one. So the main model that we are going to use here is the Node MCU ESP8266. With the help of a 16:4 multiplexer, we'll be accommodating many more lamps which can be controlled using this particular module. We are just using simply two sensors, the DHT11 for humidity sensing. That is when there is an occurrence of heavy fog, the lamps might get on, and the LDR sensor, which actually which knows the presence of sunlight, and when evening occurs, the lamps might get on. So these are the basic two sensors that will be using, and well. Up till this point, it might sound like a simple science project, but the idea which differentiates us and a simple science project is that major accidents occur due to defective lamps in the streets. So for this, we have devised a method which will store the data of the lamp that is not working into an SD card module, or it can also display it in a website. So if the technician comes over there, even during the daytime, where he will not be able to check the working of the lamps. If he can just read the SD card or just look at the website in order to get the data for the lamp which is not working, and he can easily repair the lamp, and this will help in reduction of accidents. Next slide. So these are the basic resources that we'll be using in this idea. Like I mentioned, Node MCU ESP8266, 16:4 marks, a DST11 sensor, and 16 LDRs. So this is an example of how we are going to store data of the lamp which is not working into an SD card or a website. So the switching on and off operation of the lamps can also be controlled using an app like the Blink IoT app, or we can we are open to even design an app for that purpose. So that is the particular working of the of our module, which will be installed in an area such that it controls the lamps. So suppose if a person is not able to operate an app, we can let the sensors work on its own by the use of we can let the module work on its own by the use of sensors such that it gets on and off correspondingly. So as I mentioned, the tech stack that we're going to use are pretty much simple, and Node MCU ESP8266 for as the controller, Blink app for controlling the on and off option, as minimum storage SD card for storing the lamp data which is not working, and 16:4 marks for accommodating multiple lamps. So the potential use cases are in places where people can't physically go and switch on every lamp. A person can use the app and switch on the lamps in an area. And apart from that, it is highly helpful in places where accidents occur due to the shortage of night lamps. And since the sensors we use here are pretty much accurate ones, there won't be any error as such during the switching on and off time off the lamps. So now.
When come to budget estimation, we use Node MCU model, which is approximately equal to 300 to 350, and 16:2 multiplexer model, it is 70 to 100, and temperature and humidity sensing sensor, which is of 100 to 150, and the LDR sensor for detecting sunlight, it is of 30 to 40, and the SD card for storage of defector lamps, it is of 200 rupees. The total price for 16 lamps it approximately equal to 750, and the total price for one lamp we spend is 44.65. When it comes to marketing strategy, there is no need for mankind and manpower to operate this, and it can reduce the risk of accident and theft. And we can use the external storage SD cards which can store the defected lamp. By using this, we can easily replace the defected lamps, and we can efficiently use power, because while operating in manpower we on and in morning we not off regularly, but it comes to automatic, it can automatically on and off, and we can reduce the use of power, that we can efficiently use power, and the power consumed of less carbon print can be reduced. Thank you.
How many lamp is monitored from the
So using an LDR sensor placed inside the dome, sir, the lamp product dome.
by asking that you're using 16 plus 4 months.
Yes, sir.
That means the product of 16 is over.
Yes, sir. So for 16 lamps you can control.
So you can control only for the 16.
Yes, sir. In a street, there won't be more than 16
What's
lamps.
the motto for this? What's the motto for this?
Basically, accident prevention.
You just monitor only for the 16 lamps. After that, you can able to control the accident.
So I think per street we are planning.
Just to plan the
Per street.
And how you maintain this all the data? How you maintain get the all the lamps data? Maintain in America? How?
Yes, sir.
we write the data, sir. So if an LDR and LDR is placed inside the room, sir. If the lamp is not working, there is either a problem in the lamp itself or the circuit switch. So that LDR will take the readings over there. So during the night, if that LDR senses that the lamp is not working, the data can be given to the node MCU module.
ADI sensor gives the data to the
Node MCU module.
After from the interface to the
In the SD card or the website. Whichever is
So whenever you need for that, whenever we go for that area, you should plan that place. From that one we can able to
Are you using GPS? Only 16 lamp. This also can take the distance of the 16 lamp. That will be double fold for around 200 meter. 200 meter. What is the speed of the car? After that, how it is going to control the remaining lamps?
no, sir. It's not like when the car comes and the switch on, sir. It will be on, sir. Just for the lamps working, we are doing that. It's not that when the vehicle comes, it will switch on, sir. Not like that. It will be on.
Not like status checking also. How it is check that next remaining post status. Each one having an ID.
Yes, earlier.
ID. Only 16 in the sense.
Yes.
How can you give an ID for another lamp? 16 or 30 rupees, 16 ID you are looking at. Suppose 17% is coming, 18% is coming. How to?
Actually, now I used to put the US to 16 is
Okay. You have to go further this one. Only says the hacking of the system. So all the lamp will be having a similar ID or a similar type of sensor. Okay, you have to interact with that one in the working model. You can develop that one.
Yes. Thank you.
The last participating team is Team Instrumentas.